All right, it seems like this is perfect timing for a thunderstorm. I've been waiting for all day. So hopefully we don't have any technical problems, but our team is in 3 different cities, so at least one of us should stay online, hopefully. So thanks to everyone that is introducing themselves in the chat. It sounds like we're coming from all over the watershed, which is awesome. I'll just start off by telling a little bit about the series, and then I'll hand it over to Stephanie to get right into the talk. So this is part of the MWEE Practitioners Webinar Series. So it's focused on educators within the watershed who are looking on evolving their practice in environmental education. And we put a big focus on meaningful watershed educational experiences. So I'll tell you the other ones that are coming up. Oh, thanks, Steph. She already clicked on that. So we have a number that are still coming up. We have the next 2, May 12th and the 21st, are all about the MWEEs in different contexts. And then, oh, this is actually one slide. Could you go one more, Stephanie, since I'm actually talking about it? The last one we have is May 28th, and that is going to be another colleague of ours from the NOAA Chesapeake Bay Office, and she's going to be talking about climate in the Chesapeake Bay. So you've probably already figured this out if you're here. But if you ever lose that email that we sent around, you can just go to NOAA's website for Environmental Science Training Center, and there you'll be able to find the links for all of our webinars. And you just click on the link and you join. So Stephanie, if you could go back one slide. Before we really get into this, I know a lot of us have been doing virtual meetings, but just in case you're new to GoToMeeting, just want to show you real quick how to operate. So at the top center of your screen, you should see something that says like view everyone or view something. So you can make adjustments there if you want to not see the videos or just see the slides. There's also a white bar that lives between the videos and the slides, and you can actually drag that around if you want to make one bigger or smaller. If you hover over top of the slides, you should see some buttons that appear. So this is another reminder. Make sure that your microphone is off, you're muting yourself, your camera is off, and then if you're on the phone, make sure to hit *6 so you're muted there as well. On the right-hand side, there's a few buttons that you can use during the talk. The camera feature actually lets you take a screenshot of what you're seeing. So if for any reason you want to remember that particular slide, you can hit that button, and as far as I can tell, it goes right to your desktop. So it's worked for me. The plus and minus allows you to zoom in and out of the slides, and that's just for you. And then the 2 boxes at the bottom are really helpful if you actually have 2 monitors. You can split up the display between pictures and slides. So that's just like a really quick overview of what's here. So Stephanie, if you go ahead 2 slides. So there is that camera feature if you want to share or save some of the slides. But we also do a recording. We're currently recording right now. And all of those recordings for this webinar and for all the past webinars live on a Google folder that's shared. So you can go to the Google folder. You will have to ask for permission, but permission is granted pretty quickly. And then you'll be able to, in the next couple of days, see this webinar again, and then all past webinars. We also plan to have these videos posted to the Chesapeake Bay Program's YouTube page. They have a MWEE playlist within that YouTube page. They're not there yet, but if you haven't gone to their YouTube channel, I would definitely recommend it. They have really good resources around MWEEs, and then just a bunch of Chesapeake Bay topics. So especially now in the virtual world when we're trying to teach and learn virtually, it's a great way, you can send videos to people to watch, learn a bit more about our region. So if you want to click the next slide. Very slow. I think that's all of the kind of housekeeping stuff I wanted to go over. So I will introduce Stephanie for her talk. So I don't even know if I introduced myself. My name is Krista Hogan. I work at the Environmental Science Training Center. It's a part of the NOAA Chesapeake Bay Office. And our training center is actually located in Oxford, Maryland. On the webinar, I have my coworkers Elise and Bart, and so they're going to be working the chat along with me, helping out in the background. And Stephanie also works for the NOAA Chesapeake Bay Office. So if you haven't found the chat function, you can open that up. It's that little talking bubble near kind of the top right. We'll be using that to collect any questions you have. So if questions come up, just throw them in the chat. Stephanie plans to stop a few times during her talk to answer some questions, and then we'll have time at the very end as well. And then she also plans to ask a few audience questions. So when she does that, we'll use the chat to just collect your responses. So I have a real quick intro that Stephanie helped me with. So I'll just go ahead and read that, and then she'll get started. So Stephanie directs a multi-agency program to achieve large-scale oyster restoration in the Chesapeake Bay. This includes working with state and federal agencies, academics, non-government organizations, all to set common goals to develop restoration plans, and then to implement, track, monitor, and adaptively manage the restoration work. She holds a master's in environmental science and policy from Johns Hopkins, and her background includes working as an environmental lobbyist and a fisheries scientist. She grew up sailing, and prior to her conservation career, spent 10 years working on traditional sailing vessels, eventually as a captain. Currently, like I hope everyone, she is quarantining, and she's with her family in Annapolis, and much to everyone's annoyance, has taken up the ukulele. So if you want to get going, Stephanie, I think I'll turn off my video and you can start.
All right. Thank you very much, Krista, and thanks everybody for dialing in. Stephanie Reynolds-Westby with NOAA, coming at you about large-scale oyster restoration. Hopefully folks can see my screen. And before we get started, I want to first of all thank all of you, educators of all types, who I know you are absolutely on the front lines of things right now. I'm amazed and delighted that you're able to take the time to learn about this. So thanks for everything that you're doing. I'm a parent as well, and definitely see what y'all are facing. So hats off to you. Meanwhile, oysters. So we've been working since 2011 on this initiative to do large-scale oyster restoration in Chesapeake Bay. And you will hear me use the word we again and again and again and again throughout this presentation. And I just wanted to point out on the sidebar over here that, you know, when I say we, yes, I mean NOAA, but not just NOAA. It's all of these amazing partners we have, the states, the academics, the researchers, the NGOs, who are all part of this. So just want to make sure everybody knows who I'm talking about. So moving in. There we go. So the issue in the Chesapeake Bay is that there are not enough oysters. Our population in the Chesapeake Bay is about 1% of historic levels, and that is not good for the oysters, but it's also not good for the ecosystem services that those reefs provide. The fish habitat, water filtration, other ecosystem services. Of course, when you lose 99% of your oysters, you also lose 99% of the water filtration and 99% of the fish habitat that the oysters used to provide back in the days of, you know, Native Americans and then, you know, John Smith's day. So that is the issue. And some of you may have seen videos before that look something like this, where you have 2 tanks of water, one has oysters in it and one doesn't. And if you have murky water in there, and then you wait over the course of this is probably an hour or something, or a few hours, you can see that because the oysters are filtering and eating, they do a pretty good job of removing some of the cloudiness in the water. So just one example of a really important ecosystem service. There we go. So what are we trying to do about this issue? Well, we're obviously trying to put more oysters in the Chesapeake Bay. And we've been doing this in the Chesapeake Bay for 25 plus years. You could arguably go back even further than that if you include some private aquaculture and things like this. But this idea of, you know, let's try to rebuild reefs, not just for harvest, but more immediately for their ecosystem service value. We've been doing that for a good 25 plus years, but it was much more recent than that really in about 2014 when we signed the governors of all the watershed states signed this 2014 Chesapeake Bay Watershed Agreement. That's when we really started making a unified, coordinated, large-scale effort, taking everything we've learned in decades past about how to do oyster restoration and why it's important, and made a serious sort of run at doing large-scale restoration. So there was a goal associated with that Chesapeake Bay Watershed Agreement. There's lots of goals. Today we're going to talk about the oyster goal. And that goal is what's written there: to restore oysters in 10 Chesapeake tributaries by 2025 and ensure their protection. So dissecting that goal a little bit, you would first of all have to figure out what you mean by restore, right? I mean, we know we want to do 10 tributaries, which compared to the scale we were doing prior to that, it would be like an acre here and an acre there and kind of all over the place. This said, let's do this in 10 tributaries. Let's go large scale and let's make sure we restore them. Well, first thing we had to do was figure out what we mean by that term restore. So we actually, a group of scientists and managers actually spent about a year determining what we meant by success. And very quickly going over that, we determined what it meant to have a successful oyster reef. That's things like oysters per square meter after so many years and persistence of the reef structure. But we also, because remember that goal was to restore 10 tributaries, not 10 reefs, but 10 whole tributaries, we also had to define what it meant to restore a tributary, as in how many oyster reefs do you need in one tributary before you can consider that tributary fully restored. You can kind of check the box on it. So we answered that, and the exact formula is a little bit complicated. It's part to do with how many oysters we know used to exist there, and then it's partly based on how many acres of oyster reefs we can currently restore that there without interfering with, you know, navigation and considering muddy bottom habitat and things like that. But we do have these success criteria, and from there we could actually start planning, right? So first we set our large scale goal, and again, that's the governors of the watershed states all signed up for that, as well as the federal government. The Environmental Protection Agency signed that Chesapeake Bay Watershed Agreement on behalf of the federal government. NOAA and the Army Corps of Engineers are the two main federal government players, but you know, it's all federal government involved, as well as the states and NGOs and researchers. So we set our goal, we set our success criteria. Now all we have to do is select tributaries, plan, implement, monitor, quantify each, the ecosystem service values of each, and adapt the whole thing and do it 10 times over again. So fairly tall order, but we are working through it. And so for the rest of the presentation, you're going to see this kind of roadmap down the left-hand side here, just to kind of remind everybody what we're talking about. So this is the section. This is the bullet we're on now, which is selecting tributaries. I'm happy to say that all 10 tributaries have been selected bay-wide. These 5 that I'm showing first are in Maryland: Harris Creek, Tredeavon River, Little Chaptank, Minokan, and St. Mary's River, so somewhat spread out. And then in Virginia, Great Wycomico, Piankatank, Lower York, excuse me, Lafayette, and the Lynn Haven River. Those were selected by a combination of areas that were suitable for oysters, areas that had fairly large amounts of area that we could work in that were not going to be harvested back up. We hope that what we're doing here by restoring these sanctuary or non-harvest areas eventually will also help out the harvest by exporting oyster larvae onto those harvest reefs, and also by helping to filter the water and provide habitat for non-oyster species as well. But these reefs that we're building under this program are not actually meant for direct harvest. They're set aside for the ecosystem service value. So we selected the tributaries on a combination of that and a little bit of politics and a little bit of sausage making in there as well. So the first tributary that we really went big on was Harris Creek in Maryland, on Maryland's eastern shore. And you're going to see a lot about Harris Creek in the coming slides, because what I'm going to do is kind of step through Harris Creek as a case study, because although we're adapting as we go with other tributaries, this one's the furthest along, or is it the farthest along? I can never remember. And and it's a nice kind of case study of, in broad strokes, how we're going about restoring the other tributaries as well. So I'll hand it over to Krista, and if you have questions for me.
Yeah, so far no questions have come in, so I think we can just keep moving along.
Okay, sounds good. Feel free to post them in the chat if you do have questions, because we'll take a few of these question breaks as we go. Let's see. So after we selected tributaries, the next thing we had to do was plan. Sorry, some of these are a little cut off at the top there. So this is a close-up map of Harris Creek, which I mentioned before. It's on Maryland's eastern shore. It's going to be our case study, and the blue is the water, and this whitish stuff is land around it. So it's a long and skinny tributary, and it's, I think, about 4-ish miles long. Actually, it's a little bit longer than that. And one of the first things we wanted to do here is to figure out what river bottom within Harris Creek is suitable for oyster restoration. And basically that breaks down into, is the bottom muddy or is the bottom hard? Anybody who has spent any time on the Chesapeake Bay sailing or otherwise mucking around knows that we don't have a lot of hard substrate the way, we don't have a bold rocky coast the way we do up in New England. What we have is that famous Chesapeake Bay mayonnaise that's very thick and very sticky and very soft. That's a lot of our habitat. And you can't build an oyster reef on top of that Chesapeake Bay mayonnaise because it tends to sink under its own weight and just get smothered over with more sediment washing down all throughout the watershed. So what we needed to do was start out by doing very intensive sonar surveys of the river bottom to find what is current day, present day, good hard substrate that we could build reefs on. And the gray in this map is hard muddy bottom, and the purple areas are the hard habitat. So that's our initial starting point for where within a tributary we could build oyster reefs. After that, we went out to all of that, what showed up as purple in the last slide, that hard bottom or hard benthic habitat, and we did oyster surveys on them to figure out how many oysters are there currently. Remember, we already had those pre-established success criteria at the reef level. So for the reef level for oyster density, it happens to be 50 oysters per square meter is that's our ideal target density. So you can see there's just a couple of spots here in Harris Creek. I think it's just that 1 3-acre spot that already met the metric, and frankly, it had been seeded with oysters the year before. But there were a couple other areas where the reefs were doing okay, we just needed a little bit of additional seed. And then these other areas, the colder colors, the blues and the yellows, not doing so well. 1 oyster per square meter and below, which is far cry from the 50 that we're shooting for. So we didn't want to seed in these areas that we already knew or build reefs over top of the areas that were already doing well, but we did want to target these other areas that aren't doing so well. So the next thing we did was we took this map showing what we learned and where we knew they were oysters and the areas that we wanted to target, and we opened it up to some public open houses, either in person or virtually, and got public input. We also had some community consultants, watershed groups and that kind of thing, and some scientific consultants to give us input on the plan. And then we could eventually develop a plan that said, look, here's how many acres we think we can do in, for example, Harris Creek, and this is what it ended up looking like. And that was our plan, along with a whole bunch of words around it and appendices and complicated things. But this was basically what our plan looked like visually. So then we needed to implement. Oh, and by the way, just to keep track of things here a little bit, these yellow polygons here on Harris Creek added up at that time to these polygons ended up to about 377 acres. Spoiler, we ended up doing about 350 of them. So we didn't do all of them, but we came pretty close. But how did we get there? And this is the kicker. Not all that easy to build an oyster reef for a lot of reasons, but I wanted to kind of walk you all through the steps so you have a sense of what we mean when we say, oh, we built 350 acres of oyster reefs. They basically it comes down to a few standard methodologies. And the first method we use is oyster seed only. So remember some of those orange or light red sections on the previous map where it was like, yeah, they have a few oysters, so obviously they've got some nice reef structure there. We just need more oysters. So in those cases, we were able to do kind of the lowest level of intervention, which is just to plant oysters onto the reef and monitor them a few years later, and hopefully we would get our oyster densities up. But to understand that, it's a little bit useful to pause for a minute and make sure everybody understands how oysters are made in the wild, and then how they're made in the oyster hatchery, primarily at University of Maryland, although there are a couple others around the watershed as well. So in the wild, if you have a nice healthy reef, you've got male and female oysters together in close proximity on the reef. So that's why we really wanted to get the oyster densities to high level, because the way they reproduce is that the males release sperm and the females release eggs out into the water column. So they fertilize externally. If you've got one male way over here and a quarter mile, downstream, you've got a female, and half a mile away, you've got another male, it makes those eggs, it makes it really hard for the egg and sperm to find each other. So having these reefs with really high densities of oysters together is really important for their reproductive success. So if all goes well, you got egg, you got sperm, they meet, they grow, and the oysters are actually free swimming in the water column for a few weeks. Most people don't know that. We think of oysters as sessile organisms that stay put, but they are actually free swimming for a few weeks, or planktonic mostly. And if they are unlucky, which is the vast majority of them, they fall into the Chesapeake Bay mayonnaise and they die. That soft, squishy bay bottom does not do well for oysters. They need something hard to attach to. And as we mentioned before, we don't have a lot of rocks in the Chesapeake Bay. What we should have naturally are other oyster reefs. And that's where the lucky few of these larvae would land, is on the good structure on an existing oyster reef. The spat would attach to it, that reef holds it out of the mud, keeps it from being smothered, and it can grow and start the cycle all over again. So that's how oysters are reproducing in the wild. That structure is important, and having high densities of oysters is extremely important. So how do we do this in an oyster hatchery? These are examples from University of Maryland's Horn Point hatchery, which if you haven't visited and you get a chance, I highly recommend. But they go out and collect what's called broodstock, or adult oysters from the wild, and they put them in these conditioning tanks, and sometimes they salt the water or heat the water to mimic environmental conditions out in the bay that are ideal for oyster spawning. Once the sperm and the egg are released, they actually siphon off the resulting larvae and grow them in massive tanks for a few weeks. That replicates that part in the wild where the oysters would be free swimming. Then they place the larvae, which are just the size of a grain of sand, millions of them, into a tank filled with old dead oyster shells. After a couple days, hopefully you'll get something that looks like this. These little dots are individual oysters. And then you load, that's an oyster, a juvenile oyster is called a spat. So this product is called spat on shell because it's oysters, juvenile oysters attached to old dead oyster shells. Then millions of those spat on shell are loaded onto a boat and sprayed with a fire hose onto an oyster reef. And a few years later, hopefully you get something like this. And if you're really lucky, you get something like this, which is clumps of adult oysters. And if you look carefully, you can see there's juvenile oysters even attached to those. So that's what we're really going for. So what we can do is, if we just need oyster seed, we can get the seed from the hatchery by the billions and plant them onto oyster reefs. We planted about 5 million seed oysters per acre. In other cases, this happens more typically in Virginia, you might have lots of really good natural reproduction and lots of adult oysters living nearby. What you don't have on a given reef location is enough substrate. So in those cases, we just pile substrate onto that good hard bottom that we've identified, and let nature take its course. Basically, let natural recruitment or natural reproduction populate the reef, which is of course a lot easier than making them in the hatchery. And for substrate, sometimes we use old dead oyster shell. That's not always available for various reasons. We have been having a lot of luck with a lot of substitutes, including this rock. That is my foot that you were seeing right there. So these rocks are, I don't know, the size of a soccer ball or a grapefruit, somewhere in that range, and they actually do beautifully when the oysters attach to them naturally, or when we plant the spat on shell on top. And if you are really unlucky, you need the full treatment. You have an area that does not have enough reef substrate, so you got to put the substrate down. There's also not enough natural reproduction, so you have to go to the hatchery and get your seed and put it down, and that's the seed and substrate methodology that we talked about. And don't worry, I am breathing for questions in a minute here. So Harris Creek, what does this look like? 350 acres of reefs, all within a relatively small tributary. We've been getting, the Chesapeake region has been getting some really nice national and international shine for this work. It really has become, happily, it's become a national and an international example of a success story. Just the scale of it and the complexity of it and the adaptive management and the planning and all of that. And what we're trying to do is, again, get away from that idea where we used to build, hopefully you can see my cursor, maybe we build 1 acre up here in Harris Creek and another acre over here and another half acre over here. And that was nice, but when they reproduce, the chances of those offspring finding another oyster reef were just virtually none. So we've tried to rebuild truly this interconnected network of oyster reefs where one spawns and these ones downstream or even upstream can catch that free swimming oyster larvae, and we sort of make the whole system resilient, at least as far as these 10 tributaries. And just for reference, 350 acres, if you add up all these polygons together, these green polygons, they're about the size of the National Mall in Washington, D.C. So next time restrictions are lifted and they're out there in the middle of it, imagine yourself in the middle of an oyster reef that big, and that's what's happened on Harris Creek. Let me just show you some quick before and after so you have a sense of this. Prior to restoration, this is not the same location exactly as the after video. I didn't get my act together in time for that, but this is a typical example of what we're seeing prior to oyster reef restoration. Soft, muddy bottom. This is a site that's targeted for substrate and seed, so it's one of the sort of ones that's in the worst shape. You could see there's a couple little clumps of oysters and maybe some SAV if we get lucky, but not a whole lot. Then the after video in a best case scenario looks something like this. So you're seeing some of this red-beard sponge here. You're seeing some of these other organisms living on top, a lot more habitat complexity, which is good for fish, of course, and crabs, and of course more oysters, which then spawn and make more oysters, which is what we want here. And some nice multiple generations of oysters building up, getting that reef height off the bottom, which is important because every time we get a storm event like we're having today, lots of sediment washes down through the watershed. So the higher up the reef goes, the more resiliency it might have against that buildup of sediment. Gosh, I really thought I'm going to just stop for questions here. I think we need this, and then maybe we'll have time later. So Krista, do you want to let us know if we have any questions here?
Yeah, I did see one from Susan, and I don't know if she'll need to give us a little more detail, but she said she saw something on CBS Morning about oyster farmers on Long Island that were facing some problems and wondered if there were similar issues in the Chesapeake Bay. Do you know what she's talking about? Or?
That's a great question. And Susan, I'm assuming you mean the aquaculturists, the oyster farmers related to COVID because their market for oysters has largely dried up? Is that right? Okay. I'm going to assume if it was a recent news clip that that's what it was. Yeah,
Oh,
people
Susan
mostly
said
don't.
yes.
Okay, thank you. People mostly don't sit at home and shuck oysters and slurp them down, right? It's mostly a restaurant product. You got to a raw bar, you got to an oyster roast or something like that. And yes, oyster farmers, which is a great, great sustainable way to produce seafood because we also get filtration while those oysters are growing in the water. So it's just a terrific win-win. But the market for those farmed oysters has dried up really all around the world, and we're definitely seeing that in the Chesapeake Bay as well. A lot of them are small 1, 2, 3 person businesses, so they don't they can operate on a little bit of a thin margin anyway. And right now their market is I've seen some estimates 90 to 100% reduced. So you can certainly buy oysters from your local oyster farmer. If you Google around, there's lots of that going on right now. And there definitely has been talk about maybe some relief packages that might, I think a lot of industries are likely to get relief packages, and that may be one of them as well. So yeah, we're definitely seeing that in the Chesapeake.
So you managed to answer some other questions, but we just got one from Robert who wants to know if you've begun work in tributaries in Virginia yet.
Yes, and I actually have a slide on that. We have more or less we started at least planning in all of them, and we've started putting stuff in the water in 4 out of 5, and one of them's done. So I'll show you which ones those are when we get to that slide. Thank you.
I think that's it. You can continue.
Okay, thanks. So carrying on with this one example of Harris Creek, which is, again, is just a case study. We're following these same steps in tributaries bay-wide. Once we did all the implementation, we needed to go back and monitor. And again, remember, we had those pre-established success criteria, so it made it a fairly easy task, at least in concept, to understand what you needed to go back and monitor later to see if you were in fact successful. So reefs are monitored 3 and 6 years post-restoration, mostly either by divers or by these big giant rake-looking things are called patent tongs, if you're not familiar with them, and they are traditional means of oyster harvesting, but we are actually hiring watermen and having them use that same gear to pull up a sample of the reef, and then we can count oysters and figure out if they're meeting these success criteria. Those first 2 success criteria, oyster density and biomass, those tend to get the most play because when you build an oyster reef and you come back 3 or 6 years later, what you really want to know is, are there any oysters on it and are there enough? So how are they doing relative to those 2 success criteria, oyster density and biomass? The way we structured that success criteria is we had a minimum of 15 oysters per square meter, and 98% of our reefs are meeting that minimum threshold for success. We also had an ideal target density that we were really aiming for in our planning, and that is 50 oysters per square meter, and 75% of our reefs to date are meeting that higher success criteria. So, and that's at 3 years post-restoration. Don't quite have our data in for 6 years yet, but those are mostly looking good as well. So it seems to be working in terms of monitoring. So once we've done all of this, again, then we got to go back and do it bay-wide. So Harris Creek, which we've talked about, we've completed the implementation phase. We've also completed the implementation phase on the Lafayette River. That was a much smaller number of acres, but we did complete that. The rest of these bay-wide are in various stages. St. Mary's, hopefully we will start planting this year. Minokin probably won't be until next year. We've started doing reef construction on Great Wicomico, Piankatank, on Piankatank, Lower York, and Lynn Haven. Great Wicomico had a fair amount of restoration prior to this, but we're in the midst of working on a plan under this to do some more. So various states throughout those. And here's my question slide. Do we have any more, Krista?
Yeah, we got a question from Hema, and she was wondering, are there any controversies or issues about oyster sanctuaries, for example, from watermen? And if there are, how are they resolved or addressed?
Yeah, it's a great question. If you don't mind, I'd love to hit that in one of my last slides, because we talk about the many things that we've learned in there. So I think I'll save that one, but it's a great question.
All right, yeah, then you can keep going.
Okay, thanks. So the second to last step here is to quantify ecosystem services, because yes, we want more oysters in the bay, but really, at least speaking for NOAA and some of the other partners, what we're really after, the goal that we're after, is those ecosystem services that those reefs can provide. And they, so if you put a lot of oysters in, that's great. If you can put a lot of oysters in and show or measure, quantify the services that they're providing, that is even better. So we've done a little bit of work on that. So what are the ecosystem services that the oysters might provide? We talked about oysters make more oysters, and I have a nice little video on this, which shows some larval transport modeling. So basically, this scientist said, hey, if we do all 350 acres in Harris Creek, where might that larvae end up, and might it live if it can turn into an oyster, depending on where it goes. So what you'll see here is these little purple blotches are actually individual purple dots that represent a larvae that would be produced in this modeling scenario by Harris Creek oysters. There's a day counter there, so we're starting at almost the second day. And I'll click play, and you can see those little purple dots are going in and out twice a day with our diurnal tidal cycle, right? 2 highs and 2 lows a day, but they do eventually make their way out into the watershed. And the green, I'm going to stop it here, otherwise it just starts again. The green dots represent areas where there's known oyster reefs. So if the larvae land on those, they get lucky and they have a chance of living. The ones that just disappeared are ones that landed in the mud. So this Harris Creek is an oyster sanctuary. You can't harvest there. Broad Creek right next door is open to harvest. You can harvest there. Little Choptank from about here up, Little Choptank River is a sanctuary. You can't harvest there, but you can harvest down here in the mouth, and you can harvest throughout some portions of this. So we are hoping that we get this ecosystem service of sort of a repository of brood stock that in perpetuity will always be making more oysters, and that we can stick with harvesting them in other areas. Fish habitat we talked about, which hopefully those 350 acres are also providing, and water quality improvements. We talked about a couple of the more specific ones that we have been able to measure. One is nitrogen and phosphorus reductions. Just very quickly, we tend to get too much nitrogen and phosphorus washing down through the watershed from farm fields, from urban deposition, from atmospheric deposition. That those nutrients feed algal blooms, which in turn, when those algae die, they rob, excuse me, the Chesapeake Bay of dissolved oxygen. Excuse me, one second. Excuse me. So one of the things oysters do is, as they eat, they can pull in algae, which has nitrogen and phosphorus in it. They can sequester it by making some of it into more oyster. They can also poop it out the other side and metabolize it and poop it out the other side, and then it tends to get buried in the oyster reef. So that nitrogen phosphorus is no longer biologically available, either because it got turned into an oyster, i.e. sequestered, or the poop that got buried. So the restoration, so how much is all of this worth, and how much is this happening? And I know I'm down to a couple minutes here. We'll try to zip through this. Oyster restoration to date cost about $28 million. Annually, these nitrogen and phosphorus reductions are equivalent to about 20,000 bags of fertilizer. So you can see the little graphic there. We could make 12 stacks of fertilizer bags, the height of the Washington Monument. each year. That's how much nitrogen and phosphorus these oysters on these 350 acres are removing. And that means annually, there's a dollar value assigned to that, to about very conservative dollar value, about $3 million a year. So you're looking about a 10-year return on investment there just with this one ecosystem service, which some people would argue is useful. I'm going to click through this pretty quickly because there's a lot of numbers in it, and I want to get to our last slide. But we had some economic impact analysis done, and it says that, you know, because of the harvest you can get from other areas and the increase in habitat from, say, blue crabs that you are going to be harvesting up, because even in the sanctuaries you can harvest those areas up, that 3 of the tributaries we're doing together in Maryland have some pretty high annual return on investment, $11 million annually, $23 million annually, again, against a $55 million restoration cost for those 3 tributaries combined in Maryland. So arguably some good numbers there. So adaptive management is something we certainly want to do. We want to learn and start the process all over again. So to the caller's question, what have we learned and what have been some of the issues? We have learned that oyster restoration is feasible at this scale. We'd never done it more than 100 acres, and that was extraordinarily. Prior to that, it had really been like half an acre, quarter acre, maybe 2 acres here and there. So we know we can do this. We also know it's really expensive, right? I mean, some of those numbers you just saw are absolutely eye-popping. Yin to that yang, the ecosystem services, depending on how you value that in terms of dollars, but also how much you value things like having more fish and having a cleaner Chesapeake Bay, the ecosystem services impact may be worth it. That's a broader societal question, or it may be a good investment. But again, that's a value judgment. And I don't know when we're going to learn this one. Conserving what you have is way better than getting it to 1% of historic levels and then desperately, to the cost of millions and millions of dollars, trying to rebuild it. If there's any way we can avoid being in this situation in other places, we really can. We got to deal with the pollution. We got to manage fisheries properly, the whole kit and caboodle. Pre-existing success criteria and common planning have been really sometimes slow and difficult, but they seem to pay dividends. It seems to be a useful structure. And here's to your question. Not everyone loves this effort, partly because oyster restoration is expensive, $62 million to date. That's a bay-wide figure. And remember that commercial wild harvesting, this is particularly an issue in Maryland. Some of these areas were closed as oyster sanctuaries only about 10 years ago. And now we're trying to restore them for all the things I just talked about. For those communities where, you know, they may have harvested there literally for 4, 5, 6+ generations, they can't harvest there anymore. And that is a loss. That is an absolute loss to that community. They can harvest other places, but you can't do all that harvesting in those areas either. So it is a loss. And as a result, as you can imagine, there's folks, especially in that community, who do still see it as a loss, and rightly so. We did have some mess ups along the way. Some oyster reefs were constructed in Harris Creek too high, and that posed a navigational hazard, and we had some boats run aground on it. That is never good business and did not do us any favors in terms of getting the public on board with this effort. And for those who weren't supporting it in the first place, it rightly so gave them a lot more reason to dislike it. Those have all been knocked down to the proper height, and the boaters have been reimbursed, but it still was not a good thing. Then there's the broader societal value, right, of is oyster restoration, and I put this in little quotes, quote, worth the quote cost, because you can look at that in straight dollars and cents, but you can also look at it from a values perspective. If you've harvested somewhere for generations and you can't anymore, that's a cost. And maybe down the road having cleaner water, maybe, may or may not be worth that cost, right? So there are all kinds of cost benefit analysis that individuals are very rightly doing based on individual values. We have done some public outreach around this. It's not enough, frankly. We recognize that it's a weak point, that the outreach, that when you get to this scale, you've got a big government mandate to restore 10 tributaries, signed by the federal government, signed by the state governors. We are doing large-scale industrial contracting for barges and thousands of tons of material and billions of oysters. And I think we need to be working at that scale to address the scale of the problem in the Chesapeake Bay. But the problem is we're not doing a great job of outreach. So we're trying to do more webinars like this. If anybody has any creative ideas, I'm all for it. But we're not getting quite the volunteer hours and the hands-on component of this stage. And that is definitely a weakness for sure. So my bottom line is oysters are easy, at least relatively. I should probably put that in quotes too. But people are hard, right? I mean, if we make the decision collectively as a society that this is, quote, worth the, quote, cost, and we're going to go big, we kind of know how to do that. Like, so far, we can get the oysters to cooperate, right? To do that, there is a societal cost, there is a dollar cost, not everybody's behind it. And so figuring out what the, quote, right thing to do is when there are a lot of opinions on that is a little bit harder. But that's what also makes us a democracy. So, Krista, I think I will turn it back to you for some things.
Yeah, so I was just going to finish up sharing a few educational resources. So again, if you have questions for Stephanie, please add them to the chat box and we'll get to them at the very end. So to start us off, we want everyone to know about NOAA's Oysters in the Chesapeake Bay. On this website, you can find lessons for K to 12. So for elementary, there's a lesson for each grade, K to 5. And then when you go into middle and high school, there's actually a series of lessons that you can use with students in the classroom. And all the lessons are connected to NGSS, Common Core, Maryland Environmental Literacy Standards, and you can download them for free right off the site. So next slide. So I have 3 maps to share with you guys as well. These are just in Maryland and Virginia. But if you are aware of other maps, like please share them in the chat because I'm sure people would love to know. And as you suspect, this is a great topic to explore with a map. So this first one is from Maryland DNR, and they're showing prospective areas for aquaculture leases. And since to consider these areas, you have to look at a lot of restrictions, there's actually a number of map layers that you can click on and learn more about the area. This was a tributary I zoomed into. It's just south of the Bay Bridge, and you can learn where there's oyster sanctuaries, a little bit about the benthic habitat where SAVs are located, and a bunch of other things. So next slide. This is the one that's focused on the Chesapeake River, which is on Maryland's eastern shore. So NOAA has a habitat focus area. Envision the Chesapeake as a group of community members that are all working towards making this area healthy for the environment and for the people. And on the website, there's a map that again has a bunch of layers you can click on. So not only can you learn where oyster bars, different types of oyster bars are located on the Chesapeake, but you can also learn about fisheries and some of the more current water quality data. And then I have another slide of maps, one more. And this one is one for Virginia. So Stephanie shared this with me. I was not aware of it, but it's an awesome map. It's the Virginia Oyster Stock Assessment and Replenishment Archive. So you can zoom to a tributary. In this case, it's on the James River. And you can click on an oyster reef. And what's cool is that the pop-up box actually shows you past data. So that's a graph going back into the 90s showing the oyster population that is on that particular reef. That's a really neat resource. And then I have one more bit of info to share. I think the next slide. So we wanted to make sure everyone knew that we are working with a bunch of other partners to put together the first Mid-Atlantic Climate Change Education Conference. So it's just a quick little plug for that because we just opened up registration. It will be a virtual conference at the end of June, and you can go to the website and start registering. And it's already filling up pretty quick, so make sure you look into that soon. So then you can click to the last slide, Stephanie. So just a reminder, our next webinar is May 12th. That is where you can find these archives. Give us a couple days to upload this recording, and then ways you can contact us. So before I started talking, and I was still looking in the chat, I did see one question about how the restoration projects are funded. So if you wanted to start off with that.
Sure, yeah, good question. I guess I didn't touch on that. It is predominantly federal and state funded. NOAA and the Army Corps of Engineers are the main federal funders, and then the states of Maryland and Virginia have really stepped up over the years to provide the funding, and that's definitely the lion's share of it. There's also been a little bit of some NGO work. Nature Conservancy funded a reef in Virginia, and there's been, Chesapeake Bay Foundation has done some work in both states. Most of that is funded through NOAA or through NIFWF, which is the National Fish and Wildlife, I think it's Federation. I can never remember if it's Foundation or Federation. But we did have one big donation by CSX, the freight rail company. They offered their train cars to bring train loads of shell, reef building substrate up from Florida at one point, about 2014-ish, I think. Yeah, and that was worth about $650,000. So.
All right, Bart and Elise, I'm scanning through. Do you have any other questions that came through?
There's one more from Robert. Also, what's the current administration's take on these projects? Are they supportive? So I don't know if that's Maryland or Virginia or national, but and
right.
Maybe Robert, you could chat.
Yeah, we certainly have some congressionals, federal level congressionals who are supportive of it, and then most of the rest of the congressionals, like out in Iowa, don't particularly have an opinion, and I don't know that this makes it quite on the radar of the of the commander-in-chief there. And Maryland and Virginia, they as far as the states, they both have both are signatories to the Chesapeake Bay Watershed Agreement, and both are, making progress forward, and both have ponied up literally millions of dollars to achieve this. It ebbs and flows a little bit in each state in terms of the degree of enthusiasm and active restoration and that kind of thing. But over the longer time series since 2014, really since 2011, both states have definitely been supportive and have made at leadership levels, public support for the Watershed Agreement and getting this done. The next round will be interesting in 2025 because that's when we would presumably have another Chesapeake Bay Agreement to see, are we going to re-up this? Are we going to ditch oysters altogether? Are we going to go a whole other direction to see if we can keep this going? That'll be the next big challenge.
Thank you. Well, I don't know if I saw any other questions. You've been getting a lot of compliments in the chat box, which is great.
Oh, thank you.
So thanks so much for that talk.